कैसे हैं आप लोग? I welcome you all in my YouTube channel Coding by Fun and let's get started. So now we are going to start a new series on competitive programming, and the first data structure that we will use or that we will start from is a stack, right? So I will provide you some of the quick notes also for quick revision, and also we will see the problems of a stack that are normally asked in the competitive programming or in interviews, right? So let's see the stack first. So stack, as we know, stack is last in first out data structure, or we can say like the uh, first in last out, right? So both in terms we can say that. I will explain it later also, like how it works. So first of all, let's see the some of the operations of a stack. So we have push that is used to insert the data inside the stack. We have a pop operation that removes the data from the stack. Top, so top returns the top element, but it doesn't remove the element, right? It just give the topmost element. Also there is a one more function that is peek, pwk, peek. So we can also use peek for picking or to see the topmost element of the stack, right? Size is used to find out the size of a stack, that is how many elements are there inside a stack. So these are the inbuilt function already. Here we will use Java language now. So from now onwards we will work on Java language. So this is for Java programmers or the people who are working on competitive programming in Java language. But one more thing, if you get the logic, or if you are able to catch the algorithm, then I think you can write it in your language, whatever language you are working on. So I will tell you the algorithms first, like how this question will be solved. Then you can use that logic in your whatever the language you are using, right? So that will be easy for you. So all computer programmers can watch this video till the end, and it will be beneficial for you. And if you find out any difficulties, you can comment it down. And at the end, I will provide my number also for WhatsApp. Um, I will provide you this doc file also, right? So ping me over there and I will give. So let's come to the point. Yeah, so we have is empty stake function also there, and what this function do is it checks like our stack is empty or not, right? There is also is full stack, indicates where the stack is full or not. So we can check directly by writing this inbuilt function, right? So where we use this stack, so these are some of the applications of a stack, like the balancing of symbols. What type of symbols? Like the let's say we have brackets, like opening brackets, closing brackets, curly braces, big bracket. So they are balanced or not. So this is a common question for computer programmers or for interviews too, right? So we will see all these applications or programs. In terms of programs also, we will see the code of it in Java, and also we will see first the algorithms for these questions, like how to solve it, and later on we will see the code, right? So, also infix to postfix conversion. Later on, the evaluation of postfix expression, implementing function calls, finding of span. So these are some of the applications of stack, right? Undo sequence in a text editor. So whatever the last thing you have done will be the undo first, right? So this is the implementation of a stack. You can say like in real time we are using the stack. Also you can, the very basic example of stack is like the arrange the collection of plates, right? So you have a collection of plates, and whatever the plates you will enter, you will keep on the last, you will pick up that first, right? So this is what the last in first out data structure. So the how many ways of implementing a stack? So simple array-based implementation that we always use, right? The array-based implementation. Second is dynamic array-based implementation, and also we have linked list implementation. So these are the some of the implementation of stacks. So simple array-based implementation that you know, like you are inserting the data inside a stack. That is a simple array based implementation. So let's see the dynamic array implementation, right? So what does the dynamic means? Dynamic means the initial size of a stack. You don't know about it, right? So what you will do? So let's read it. What if we increment the size of the array by one every time the stack is full? So initially there is no, you haven't defined any size for the stack, right? So that's why it is dynamic. Now your stack is full, or you are inserting your data and your stack is full, right? So what you will do, every time you will just increase the size of array by one. So what happened? The push increases the size by one and pop decreases the size by one. So whenever you will pop, you will decrease the size because it's a dynamic array. So whatever you want, you can do with this stack, right? To increase the size, you can decrease the size. So problem with this approach is this way of incrementing the array size is too expensive. So why so? Let's see. Let us see the reason for this. For example, at n equals to 1, to push an element, create a new array of size 2. So let's say you have a stack and there is only one element and it is full now, right? So what you will do, you will make another stack and you will, the size of the stack will be the 2, right? And you will pop this one, pop a element from this initial array and you will place it in other stack. So let me show you just one second. Yeah. So what I was telling, you have a stack. Initially there is element 1, right? So now it is full. So what you will do, you will increase the size by 1. Now you will pop this one from here and you will push here. And now you can place the second element or at the top. Now it is full. Now again you will make another stack of size 3. And what you will do, you will keep on popping and pushing it inside the stack and you will insert the another element. So this is what you do. So the problem is, yeah. So here you are making too much popping and then pushing the same elements inside the other. So it's too expensive. So let's see the reason more clearly. The new element, yeah, at n equals to push an element, create a new array of size 3 and copy all the old array elements to the new array as I said. Wait, let's remove this one first. Yeah, and at the end add the new element, right? Similarly, for n equals to n minus 1, if we want to push an element, we will create a new array of size n as I said and copy all the old array element to the new array element and at the end add the new element, right? So what we were doing, we were making the new state of size and we were adding the new element, right? So after n push operation, the total time complexity will be like, initially we was pushing one element and two element and then three element until n minus 1 we will, in the new stack we will push the n element. So the total number of push operations, we will have the order of n square time complexity. That is too expensive. So we come up with a new approach, or we can say the alternative approach, that is repeated doubling. So what we will do, every time we will double the size of the previous stack. Let me explain you. So initially, let's say we have a size of, okay, yeah. So initially we have a size of, let's say, one element. Next time we will double the size for it, the new stack. Now this one. Now next time whenever the stack is full, we will make a new stack of double the size. That is, size is 1, 2, 4, and here the next time it will be 8. So this is what the repeated doubling method is, right? So let's see it. Yeah. So let us improve the complexity of using the array doubling technique. The array is full, create a new array of twice the size and copy the items. With this approach, pushing an item takes time proportional to n, not n square. So let's see how it is n, not n square. So let us assume that the initial we started with n equals to 1 and moved up to n equals to 32, let's say. So that means we are doubling the size, like the 1, 2, 4, 8, 16, and then 32. The other way of analyzing the same approach is like at n equals to 1, we want to add or push an element, double the current side of the array, and copy all the elements to the old array to the new array. And at n equals to 1, we do one copy operation. At n equals to 2, we do two copy operations, and at n equals to 4, we do four copy operation. So let me also explain you this thing. Yeah. So initially we have 1, and at the time it is full, we will make a new array of double the size. We are copying this element, inserting new element. Next time, if this is full, we will make a new stack of double the size. We will copy the elements 1, 2 from here and inserting some other elements. These are new elements, right? And these are old. So every time what we are doing, we are just copying one. From here we are copying two elements, then we will copy the four elements. So this is what it will be like, right? As you can see here. Okay, let me remove this thing. Yeah. So what will be the sum of this thing? 1 plus 2 plus 4 plus 8 plus 31, which approximately equals to 2 twice the n, right? So the time complexity for this will be the n, not the n square. So the interviewer may ask about this thing, like how you will implement a dynamics array, or you can say dynamic stack, if you don't want to initialize the size of it initially. So you can explain these two approaches, like the dynamic array implementation and the repeated doubling. So this will be the impressive part if you will, like you are optimizing your solution here, right? So now later on we will see the problems on stacks in the next video. Otherwise this video will be too large, so we will see the problems from the next video. If you like the video, you can comment it down, and if you want this doc file for the reference, for the and also for the revision purpose, you can message me on WhatsApp, and I'm writing my WhatsApp number here. So this is my yes, so this is my WhatsApp number, 9039848118. You can WhatsApp me over here. I will give you these doc files, right? So I will make a doc file for every data structure. So we are starting from stack, then we will continue and we will use some other data structures, and I will make doc files for them too, right? So currently I'm working on this doc file. So you, I will give you at the end, right? So whenever we will complete all the problems on stake, I will even write down the questions with algos also. So we'll see you in the next video. Okay, bye bye, take care.